Hi, everyone, and welcome. For me, it is a pleasure to be here and an honor to have the opportunity to share this presentation with you. My name is Victor Redondo Quiroz, and I work as a staff engineer for the company Veritas Automata. Veritas Automata and Hivnet specialize in the creation of autonomous transactions processing platforms. The Hivnet processing platform allows our clients to securely process transactions whenever they need to. Today, I'm going to be presenting this talk titled Pixels to Pods, a front-end engineer guide to Kubernetes. Yep. The agenda for this presentation consists of the following topics. We will discuss how the idea of giving this presentation originates and some of the effects that the adoption of Kubernetes has had on my engineer, mainly focused as a front-end developer in my daily workflow. Then we will have a brief introduction to what Kubernetes is and its purpose as a tool. We will explore some important points regarding why engineers with specializes in other branches like frontend should consider incorporating Kubernetes into their areas of knowledge and expertise. Next, we will briefly review Docker and application containerization. Then we will cover some fundamental aspects of Kubernetes beginnings at least those that, in my experience and experimentation exercise, were essential to start taking my first steps and delivering value to the organization where I work. Having understood what Kubernetes is, we will then see how Kubernetes applies to our daily workflow. We will explore some tools and that help me in my adoption and exploration process in Kubernetes. Finally, we will discuss the conclusions I reach through my learning process and I open the space for questions and make comments. Also, there is a QR code that I will share. You can scan and contact me by LinkedIn in case you want to talk about similar topics or you've got questions or just want to get in contact. Okay. Before continuing, I would like to introduce myself and talk a little bit more about who I am. As I mentioned earlier, my name is Victor Redondo Quiroz. I work as a staff engineer at Veritas Automata. I'm passionate about outdoors. I enjoy camping, whether it is by the beach or in the mountains, hiking, fishing, surfing, among other outdoors activities. There's no complete outdoor adventure without a good barbecue. I love having barbecues with my family and friends. The title I decided to give this presentation is From Pixels to Pods. So, what that name? Well, my professional trajectory since my beginnings, I have been mainly in the front end area. I have the extensive experience with any tool within the JavaScript ecosystem. I have also been able to collaborate as a full stack engineer in some projects, although I do not consider myself a backend developer as my strength. In my current job, the need and the possibility to collaborating not only in the development of solutions for front-end applications have arisen, but also in the management of applications in Kubernetes. Now, the big question is, how can one adopt knowledge in a tool as complex as Kubernetes, along with other of its understandings, such as Docker, quickly and efficiently to deliver value to the organization you work for? Well, in my learning process of Kubernetes, I have been able to identify what I consider is essential for any engineer who wants to undertake the journey of adopting this tool as part of their workflow and start adding more value to the organization. In my case, I have been able to start collaborating with other team members, creating plans to deploy application to the edge devices, developing documentation, understanding how the components or applications are deployed in the cluster and how they connect to each other. Besides setting up my local environment for testing and experimentation, this has been a great help not only for my professional field, but also for my professional growth. I hope this presentation is beneficial for you, and like me, you can soon be taking your first steps in Kubernetes. Okay, but what is Kubernetes? Kubernetes is an extensible and portable open source platform for container and service management that allows both declaration and configuration of these containers and services, as well as their automation. Now, this sounds somewhat complex indeed, but to understand why, we need to understand its origins. So, if we look at the trajectory of time, we start with the traditional area of deployments where organizations use their own local servers to deploy application into production. It was a very manual process, not automated, and hence difficult to repeat on a mass scale. Little control over resources, which caused many performance problems. Any issues in production was a complete chaos. It was almost easier to reboot and start from scratch. Then came the era of virtualization, where we start seeing some improvements. We could limit the resources assigned to a virtual machine, run multiple virtual machines simultaneously on the same physical server, improve security by restricting the access to the information between applications, and reduce hardware cost. And then we see the area of containers, which has some similarities with the virtual machines, but the way we virtualize application and containers is more portable. It allows us to share resources across the same host operating system, and this characteristic makes containers much lighter and has portability across various cloud providers and operating system distributions. Why should a front engineer bother to learn Kubernetes? Well, here are some reasons that I found, and surely there are many more, but in my experience, I have found the following. Improve collaboration. Learning Kubernetes enhance collaboration with your colleagues, especially with the DevOps. How many times we have faced issues in the CI/CD pipeline where something's run fine on the machine but fails on the CI/CD? Understanding the containerization process of your application allows you to dive into the output logs of the CI/CD, comprehend the problem, and grasp which step is failing and why. This awareness enables more effective and efficiency communication with DevOps colleagues when troubleshooting deployment issues. Understanding application de- deployment. Understanding how your applications are deployed help us to comprehend the coordinating of communication between them. For example, how your front-end application connects with a Node.js backend that is exposes an API, and perhaps that API is being not deployed on the same container. Understanding architecture and infrastructure. Understanding deployment concepts provides insight not only into application architecture, but also into the infrastructure. This understanding is crucial for designing application and identify potential improvements in the infrastructure. In his career opportunities. Lastly, the impact of these skills in your resume is significant. Combining Kubernetes knowledge with front-end expertise can make your profile stand out to recruiters, turning into the magic unicorn they seek. This exposed can lead to better job opportunities, salaries, and career paths with growth opportunities. Containerization. So, as we have seen the area of containers, they made the way that we virtualize our application even more portable. We can share our containers and be sure that anyone with whom they are shared will be able to run the container and the application with it the same way. Specifically, Docker uses a concept called Docker image, which is a standalone executable and lightweight package that includes everything needed to run a piece of software. Your application, including code, runtime, libraries, and system tools, images serve as a blueprint for building containers, allowing this process to be simple and replicable at scale. Initially, Docker was the default container runtime solution for Kubernetes. However, over the time, Kubernetes created the container runtime interface. so that other containerization solutions could also be supported by Kubernetes, such as RKT, Containerd, and among others. So, as we had seen in the area of containers, containers came to make the process of organizing, distributing, deploying, scaling, and managing containers even simpler and, above all, more automatable. It is important to emphasize that here that Kubernetes is not only a platform for orchestrating containers, but it goes beyond that. At the same time, its focus goes hand by hand with automation, and this is consistent with the fact that Kubernetes stands out in environments where scalability is needed. Now, there are many concepts that we can learn within the world of Kubernetes, but we will focus on those that were in my learning process. Pods are like pixels, where a pixel is the smallest unit of measure in a screen, and the screen allows image to be displayed in high or low definition, but in the end, everything is composed of these pixels. Similarly, pods are the smallest deployment unit in Kubernetes, representing a single instance of a running process. They can encapsulate one or more containers, share resources, network, storage, etc. Deep side a container being able to run multiple applications, the recommendation is to follow the principle single responsibility. Do one thing, do it well, as it allows greater flexibility, maintaining our application and also aids for scalability. Nodes. Nodes are individual physical or virtual machines that together conform a cluster. Each node run a clustered runtime like Docker and can host multiple containers. A cluster is a set of group of nodes that together run applications inside containers. The cluster consists of a control plane, which provides the cluster with resources to manage nodes and applications. Services are the layer of abstraction that allows exposing a group of pods as a service on a network. They provide a stable entry point to the functionalities provided by the pods, allowing communication without needing to know the details. For example, if we have our application, let's say if it is an API, and we want to have three or two pods running for our API, this allowed us to have a certain level of fault tolerance. Clients of this API don't really care about how many pods are running. What matters is getting the functionalities of this API. This is where the service abstract those details, defining that a stable entry point for our clients. And finally, we have the deployments. Deployments is basically how we declare or describe the desired state in which we want to run a group of pods. To understand this behavior, the simplest example is the functionality of a thermostat. Normally, the thermostat displays the current temperature, and if we want to regulate it, we indicate the degrees in which we would like the temperature to be, and the thermostat will call the component that regulate the temperature until we get the desired temperature. This means that K3S Kubernetes, will take our deployment manifest and try to base on its content to deploy the application and bring it to the desired state. Now, understanding these concepts, what can we do? What are they good for, right? Well, we can see some of the advantages that we wouldn't have without Kubernetes. For example, rolling updates, the process by which we can, through Kubernetes deployment, make updates to our application guarantees zero downtime, and it's gradually replaced the pods associated with the old versions for our applications with for our with for our applications with the new version. Rollbacks. If a problem occurs, it's extremely simple to reverse the process since the process is defined as therefore transparent for Kubernetes to apply it. Scaling. It is also something super interesting. A project I had in experience of seeing how the API we had struggled to resolve certain requests due to the way the deployment process was handled in production. It was impossible to think of something like having replicas of our API that could simultaneously handle these queries. Kubernetes make this process much simpler. Not only we can do this by running a command, but we can also somehow automate this process. How Kubernetes fits into the front end work, right? Um, I have realized that it is essentially to broaden our perspective and understand that our application is vital component within a large system, that this system is being used by the engine that is Kubernetes. The more we understand and comprehend the implications of having our application deployed into Kubernetes cluster and being able to intercommunicate with the other applications also deployed in the cluster, the better our decision making and problem solving skills will be. While it is true that our conventional front-end application operate on devices with a web browser, it is important to mention that if the goal is to create a work with modular architectures oriented towards microservices, then Kubernetes plays a fundamental role. It streamlines the development and deployment process, simplifies the updating of active applications, and then rollback procedures if problems arise. Kubernetes promotes collaboration between teams, offer automatic scaling to optimize performance, load balancing functions, traffic distribution across multiple instances, and we can track and monitor. There is a talk about readiness and liveness in K3S ballet choreography that my colleague Eder Rojas will give, which is related to this topic as well. If we want to understand the broader implication of Kubernetes in our development environment, we can successfully execute our projects and contribute significantly to our team and organization's objectives. This is a list of some of the tools I have the opportunity to work with when I was starting my learning process within Kubernetes. These tools help me interact with the cluster in a simpler and more user-friendly way without losing the robustness we seek when handling a cluster locally. Helm. Helm is a package manager that simplifies the deployment and management of application through the use of charts as templates that pre-configure applications definitions. It facilitates the process of defining, installing, deploying, and updating complex applications in the cluster. Minikube is a tool that allows us to run Kubernetes cluster on our local machine. It is specifically designed for developers uh, and testing of applications, allowing developers to experiment with some of the features of Kubernetes, test configuration, deployments, applications, etc., all in an isolated lightweight environment. KNIS. KNIS is the simple tool that truly allowed me to move around the Kubernetes cluster very quickly because it provides a very intuitive navigation interface. Now, from my experience, KNIS was one of those tools that really boost my learning process. It's very easy because of the way that they build this graphic user interface, very intuitive. So you can move between. It's not that you can just navigate through the cluster. It's also that you can do other miscellaneous tasks, like for instance, do a pour forward of a service or updating a manifest, and then after updating that manifest, getting it applied is very friendly for those who doesn't know kubectl, which is the next tool. Kubectl is the command line for interacting with Kubernetes clusters. It allows you to execute commands against Kubernetes cluster to deploy applications, inspect and manage cluster resources and view logs. Basically, you can do whatever you can do with kubectl with KNIS. The thing is that KNIS is something that you can install in your local environment, but probably when you are going to a production environment, KNIS is not going to be there. Production environments tend to just install, what is required. So, it's very, you will not find KNIS in a production environment. So that's why I recommend you to use KNIS as a way to, experiment on your local environment. But once you already know what you are looking for, then try to translate that thing that you are doing in KNIS to how would you do it with kubectl, because kubectl is probably the way that you're going to be performing your operations and commands in a real production environment. Okay. And conclusions. No matter what kind of programming work you do, learning to use tools like Kubernetes is really helpful. It teaches you all about setting up, growing, and fixing your programs when they are actually being used. This makes you a better in handling your project from start to finish and helps you work better with different people and groups. It also opens a new chances for you by letting you grow your career in many directions, not just by how long you have been working. By using Kubernetes, you are not just improving your technical skills, you're also getting a big picture with that helps make the programs you work a stronger and more flexible. So you can do it too. Um, HiveNet. So HiveNet is a platform for creating distribution solutions with trusted transactions between the cloud and the edge. HiveNet is basically the platform that we are building at Veritas Automata, and HiveNet used Kubernetes, in its core as a solution for managing the distribution systems. Um, because of my journey that I went through learning Kubernetes, um, I can confidently say that it helps me on a lot on not just being able to start collaborating with my company that is working on this HiveNet platform project, but also it has helped me to be able to communicate way more better and understand faster some of these concepts that are very fundamental um, things that we require in our organization due to the projects, the nature of the projects that we work on. If you want to learn more, read my thought leadership blog by scanning this QR code. There you will find many other topics of your interest written by my colleagues and I. If you want to contact me by LinkedIn, again, you can scan this QR code. I'll be happy to meet you there. I hope that this talk has been of help in your learning journey of Kubernetes, and thanks so much for watching. Bye.